uh, where's my open word? Okay, so I think I'm recording. Let me check. Yes, okay. This is 2.10 and 2.18 notes for the periodic. أول شيء because 2.10 it wasn't in the material for any of the CAs. I don't know, the regional decided to skip it. Uh, so it wasn't in the material of any of the CAs. So I don't know how they're gonna ask it in the exam. هلا okay, we're gonna do quiz in a bit. I'll post quiz. But just so you understand, the electric field. This is 2.10. This you go to the notes, electric field, and here. بعدين عندك ال 2.18 كمان I'll explain it in a sec. بس let me start with electric field 2.10. Electric field, it's the region where the particles are subject to an electric charge. It wasn't written in the book, but it's in one of the past papers, which I will solve and post later on. But for now, you need to know that the electric field, it's a vector quantity because it has a direction, okay, and it has a magnitude, okay. It has a magnitude and a direction, okay. What's an electric field? Let's say you have this box here, okay. Similarly to a magnet, let's say you put, I don't know, you put a metal here. We get your magnet over here. Obviously, it's not going to attract, but as you bring your magnet closer, it's going to attract, right? That's how the electric field kind of works. So, similarly to a magnet, okay, if you bring a charged object, let's say you have a positive, I don't know, okay, this is positive and this is negative. Okay, right now they're not going to attract, but as you bring this positive object closer, it's going to attract. Okay, so the electric charge, the electric field, it's the region of particles that are subject to an electric force. Okay, that's how the definition is. It's in a past paper later. I'll go to it later. But for now, you need to know it has a direction and a magnitude. It's a vector. Okay, it has a formula. You should know that its magnitude is just the force divided by the charge. It's an electric field. How much force? How much force per electric charge? Okay, so the electric field E, I should have written a vector symbol over here, is equal to F over Q. Okay, so electric charge is a charge feeling the electric field, right? So how much charge is feeling the electric field? So force divided by charge. A uniform electric field is characterized, uniform means yani balanced, right? Is characterized by parallel lines of field and has the same magnitude and direction at any point in space. And electric field lines, they always flow from positive to negative. Why? Because current flows from positive to negative. These are the 5 examples that were in the book. You need to know every single one. Okay, here. This is about the positive charge. We know it always flows from positive to negative. So if it's a positive charge here, what's gonna happen? They're gonna move away. If you're asked to draw, and you will be asked to draw 99%, because I think I saw 3 past papers so far that had to do that are in the material. Because like, good look, MS, you have these past papers. Oh, they updated it. Wallah, they were more. When was this updated? Yesterday. Yeah, he updated them. He removed some past papers. Interesting. Anna, I saw. What was this? Oh, and then he's including for the CA good questions that you have to solve. Okay, forget about this. But okay, I think I'll solve these. I'm solving the whole course. Yeah, so it was 8 past papers. Let me see. Wait. Yeah, I have the old material on my tablet downloaded from before. Yeah. So he decided to change the material. He took out 3 past papers. I think on the safe side, when I record, I will solve the old material. Uh, I'll solve them. Yeah. Or I'll solve these 5, then I'll solve the extra 3 on live on Sunday. Okay. Uh, I don't know. I'll see later. Okay, and then he also added these in the CA material. So I guess the physics region is trying to be a bit nicer. خفف عليك والشغل. Which is very rare coming from the physics region. Anyway, let me see. And where was I? I was here in the electric charge as a field. So it's always moving from positive to negative. Okay, you need to know how to draw all of these. Okay, you need to know how to draw them. If you have a positive charge, it's gonna flow away. So you're just gonna draw away, right? If there's a negative charge, if there's a negative sphere, you put it towards the negative sphere, like here. See here, you have positive and you have negatives. You're gonna draw lines like this. You can't listen. Don't put this, please. Don't put just like this. This is completely wrong. Okay, you have one in the middle, but command it's gonna go like, okay, well, not like that. It's gonna go like this, or like this, or like this, or like this. Henne, in the question, they'll specify how many arrows they want you to draw. Okay, so here again, this is E. If you do draw it, put a nice E beside it with a vector symbol. Okay? Just take to be on the safe side. Because I didn't, and look what my teacher wrote for me. He put for me here. And then if you have negative, you know it's going to be flowing opposite to this one. This one, they're going away. This one, they're going towards, right? You just put it towards. If it's just a negative sign, then you go towards a negative. Here you have positive, you have negative. When you have positive and the negative plate, this was in one of the past papers, you just draw 5. In the past paper, it asked you to draw 5. Okay, they gave you a sphere, they gave you a plate, but they didn't tell you what the charge is, but they gave you a circuit. And they gave you a circuit like this. Okay, and I'm gonna go to the paper later when I record it. But this long part of the battery means positive. So this is the positive side. This short side is the negative side. So this is the negative plate. This is the positive plate. And they asked you to draw 5 arrows. You just go like this. 1, 2, 3, 4, 5. When we get to the past papers, I'll explain how you have to draw it specifically. But for now, this is just how you draw. This one is important. It came in a previous periodic. Okay. They give you the diagram, and then they give you like a few numbers. Someone sent this on the Sabbath group. Okay. And they give you like 4 here, and they give you 5. Okay. Akid, they don't write for you this stuff. Okay. They don't write for you this. Okay. They asked for you, where is it neutral? Here. Okay. Where is this neutral? You'd say 4. Okay. Why 4? Because do you see any charge here? Do you see any arrow? No. So when you have two positive, Akid, they're not going to go towards each other because positive repels positive. So that's why there's nothing here. So we call this the neutral point. Okay. So they all go away. They all go away. And then they asked where is, I'll put the 5 here. In what region is the electric charge the strongest? It would be here. And the reason for that apparently is when the electric charge is the strongest, the arrows will be the closest together. Okay, this is very important. Know it because apparently it came before, and I don't remember seeing this in the book. That's why I'm telling you guys. Okay, an electric field is a quantity that has both magnitude and direction. E equals force divided by charge. The SI unit is Newton per Coulomb because the unit of force is Newton, unit of charge is Coulomb. And this is the neutral point. Okay. Hala 2.18. Okay, resistance. You need to know Ohm's law. Ohm's law is not V equal Ri. I don't know why I wrote it like this. It's R equals V over I. This is Ohm's law. If they ask you what's Ohm's law, it's this, not this. This is just the equation. Listen, this is just the equation. But the actual law is this. This is the law. Okay? Please don't mix it up. Okay? This is the equation. This is the law. Please tell your friends, in case, some people, they don't watch my notes video, they just read them themselves. Please tell them yourself. The unit of resistance is akid ohm, and it's equal to 1 volt divided by 1 ampere. Because this is ampere, this is volt, ohm. Okay? Anyway, Ohm's law. Very easy. Okay. What's the definition of a resistor? A resistor is, a resistor that has a constant resistance satisfies Ohm's law. And what do we call it? An ohmic conductor. They will ask you 100%, what is an ohmic conductor? You will say it is a resistor that satisfies Ohm's law. Okay? That has a constant resistance that satisfies Ohm's law. Because some resistors, they are called variable resistors. And those are not ohmic conductors. Why? Because they change. They don't have constant resistances. Okay? So ohmic conductors are those that satisfy Ohm's law. And it is a constitutive law, it's idealized behavior. So it's not exact, it's called idealized. Okay? These are all questions that could come multiple choice, huh? It's an idealized behavior. It's never exact. It's not like a law, like Newton's law, F equals ma. That's a law. This is a constitution. So it's a constitutive law. It's idealized. So he just kind of assumed it. Okay. What is the law? This is the law. R equals V over I. Not V equals Ri. This is just equation. This is the law. Okay. Here, I'm going to mention this as even though it's an exercise in the book. I don't think they even got it in the quiz or course revision, but it was in the book. So what they told you is they gave you the EMF as 5 volts. They gave you the voltage in they gave you the potential difference was 4.5 volts. And they asked you to, they said the current is I don't know, 2 ampere. Forget about the numbers here. Yeah, forget about the numbers here. Basically, they asked you what is the value of the resistance. Okay. What you're going to do, we know R equals V over I. صح? Here, what's our voltage? Okay. The resistance, no, the one that was lost. So always you subtract these two. Okay. 0.5 divided by 2. So like, let me go over what they did in the question. Okay. This is in case they give you two voltages, you subtract them, huh? Okay, like here they gave you the first voltage is 5.5, they gave you the first current is 1, gave the second voltage is 5, they gave you the second current is 2. I think they're asking you to find the resistance. Hold up, let me see. Yes, yes, yes. Yeah, so they wanted you to find the resistance and they wanted you to find the energy. Okay, if you ever get a question like this, okay, and they give you like these four, okay, we use the equation. Whenever you have two voltages, use the equation R equals E minus V over I. Okay, what did I do? And I want to find E, right? So I'm gonna keep E alone. Okay, so what do? I rearrange the equation. R times I becomes Ri equals E minus V. Take V to the other side. Ri plus V is equal to the energy. Okay, so we have two cases, right? So we're gonna say we know أول شيء in a circuit the EMF is always constant, right? The EMF is always constant. It's always constant. So that means the EMF in this case here is equal to the EMF in this case here. Okay, so we can say E is equal to E, right? E1 is equal to E2. Let's say E1 is equal to E2. What is E1 equal to? E1 is equal to R, we don't know it, times the current I1 plus V, right? Which is 5.5. Well, E2 is equal to R, again, we don't know it, times the current 2, I2, 2, plus V, which is 5. So you're going to get that this is equal to R plus 5.5, and this is equal to 2R plus 5. And we know that they're equal, so can I just equal them to each other and find the resistance? Yes, you're going to get R equals 0.5 ohms. But Walid, aren't they asking for energy? Well, they're asking for both. They're asking for the EMF and they're asking for the R. Okay? So now we can just substitute in the EMF. We know that any of the E's, we can just substitute R. In this case, we can just substitute 0.5 as R times 1 plus 5.5. You get 6.0 volts. This is how to solve this type of question in case it comes. Because these questions, they don't put them in the quiz or course revision. They're book questions, huh? And I هيك أنا حبيت to show you because I felt like they'll bring this. I don't know. The regional دايما he likes to get questions from the book. Okay. هلا so far easy. Just remember the EMF is always equal. Sometimes they can play with the current, they play with the voltage, but the EMF always stays constant. So that's why you find the EMF1, you find EMF2, you equal them to each other in case it comes. Okay. Resistivity. هلا resistivity it's kind of like resistance. Okay. بس هلا it's like something else. Resistivity, it's a constant. Okay. You should know this is the equation. R equals rho L over A. Okay. For any conductor, this is how it works. To find the resistance, it equals the resistivity times the length of the conductor divided by the cross-sectional area of the conductor. Okay, in other words, you could say R is directly proportional to L over A, right? So R is directly proportional to L over A. When you say something is directly proportional to something, that means R equals something times L over A, a constant. And that constant is resistivity. They're always going to give you, if you remember, like Q equals, remember when they did Q equals MC delta T? This C was a constant and they would give it to you in the question, right? Similar to that, P, as this rho, we call it rho. This symbol is rho, not P. This rho, that's a constant. For every material, every different metal, it's different. So they would give you two in the question. So you just need to know R is equal to the resistivity times L over A. The proportionality constant rho is called the resistivity, and it has a value that depends on the material of the conductor. This you have to know, okay? This can come multiple choice, okay? And then I wrote for you a note here because it was in the book. Sometimes they say rho divided by A, they call it lambda, okay? And instead of this equation here, R equals rho LA or rho L over A, they change rho over A to lambda, right? And they just multiply it by L, okay? This is called the linear resistance of a conductor lambda. Sometimes they tell you, they give it to you. They tell you lambda equals, I don't know, 6. In that case, do you use this equation? No, you just use R equals lambda L. Okay? Uh, Yeah, that's it here. يعني هون they gave you the resistance, they gave you rho, they gave you A, and they're trying to get you. They want you to find the length. You just, guys, you just substitute. والله. Length would be equal to, take P to the other side. It will be R over P, as the R over rho, and then multiply by A on the other side. It's gonna be like this. See, it comes like this. You see, and then you just substitute the values. You'll get L. Not hard. But please, please, guys, please don't forget. Like, see here in the question here. I'm gonna solve this in the course division, but they tricked you. They put for you centimeter. Okay, make sure to convert everything to meter. Okay, everything has to be in meter or meter square. When I get to it in the, if you want to convert, this is not, this is ohm over centimeter, right? Okay, if you want to convert from centimeter to meter, you multiply by 10 to the power of -2. You divide by 100. So you multiply by 10 to the power of -2. Down, but it has to be down. Okay, I'll explain this later, how to convert. This will be in the course division video. For now, thank you for watching this video. That's just notes. حبيت هيك to put them. You need to know these, okay?